Well, Einstein says the universe is a bubble. We live on the skin of the bubble, and the bubble's expanding. That's called the Big Bang Theory. String theory says there are other bubbles out there. There's a bubble bath of universes. Big bangs are happening even as we speak. So we have this bubble bath of universes.
Right.
So there was something before the Big Bang.
Your model isn't, is it a Big Bang model with an initial emergence out of nothing and then eventually a collapse back to that?
No.
No. So,
No.
okay, so how do you conceptualize that?
Well, first of all, it is a Big Bang model. In other words, there is a Big Bang, but the Big Bang was not the beginning.
What if the Big Bang wasn't the beginning of everything? What if the creation of our cosmos was actually just one of countless Big Bangs, and new universes are still being formed out there today? Well, then we would have arrived at the exciting theory of chaotic inflation, and thus at a thesis that has now been given new impetus by an unexpected discovery made by the James Webb Telescope. That's not all. Based on the data collected, a team of experts has even concluded that our cosmic world was only created by merging with another universe. A simple question, a complicated debate. Although the discussion about what actually came before the Big Bang seems superfluous from the outset, not all experts agree on the simple answer of nothing. However, this was not the case for a certain Stephen Hawking, which is why the genius, who died in 2018, could be quoted as follows on this subject. The question of what was before the Big Bang is just as pointless as asking which direction is north of the North Pole, because time itself only began with the Big Bang. This is an event that cannot have been caused by anything or anyone. The laws of nature themselves tell us that the universe can come into being without the need for energy or a cause. So far, so clear. And yet we should not forget that there are other renowned physicists who take the opposite view. For example, Michio Kaku is convinced that there was something before the Big Bang, and that string theory can even give us a detailed insight into the mysterious phase before the cosmic beginning. Quoting Kaku, Einstein said that the universe is a kind of bubble that is expanding. However, string theory says that there are other bubbles out there, a whole bubble bath of universes, and if string theory is correct and such a multiverse exists, we can also say what happened before the Big Bang. The Big Bang was the collision or the splitting of universes. String theory does indeed come up with some remarkable conclusions that sometimes test our powers of imagination. Fundamentally, it's based on the approach that the fundamental objects of physics are not point particles but one-dimensional strings, or, in other words, strings or threads that are found inside every particle. Applied to higher contexts, string theory, in turn, states that every conceivable world also exists. In other words, the fact that life has unfolded in our universe was by no means a mere happy coincidence, but rather an inevitable consequence. After all, among the countless universes out there, there must be one in which the laws of physics fit together so perfectly that life arises. But whether there is just a single universe or a whole cosmic foam bath, how do we even know when and how the universe was created? To understand this, we have to turn back the wheel of time to the 1920s. That was when astronomers first realized that most distant galaxies are moving away from us. Later, however, it became clear that it's not the galaxies that are moving through space as they flee, but rather that space itself is constantly expanding. Once experts had uncovered the expansion of the universe, they were also able to look at it in reverse and finally calculate back to a point at which the density of matter and energy is infinite and all spatial distances are zero. Consequently, they had arrived at the original singularity and thus at the extreme starting point from which matter, space, and time emerged about 13.8 billion years ago, according to the cosmological standard model. However, a phase occurred immediately after the Big Bang in which the universe expanded at an absurdly rapid rate. In detail, Experts assume that the universe expanded by a factor of 10 to the power of 30 to 10 to the power of 100 during this cosmological inflation, and that, mind you, in a period of time against which the blink of an eye takes an eternity. However, it should be noted at this point that we are still a long way from understanding all the background to this extreme cosmic growth spurt. On the contrary, in fact, inflation still represents one of the greatest mysteries in cosmology, and it's still disputed today whether it actually happened at all. Supporters of the inflation theory assume that there was, or is a special field that has significantly influenced the uninhibited expansion of the cosmos, the so-called inflaton field. Depending on its state, this field causes the universe to expand, stagnate, or sometimes expand at a ridiculously fast rate. Assuming that the inflaton field was in a false vacuum shortly after the Big Bang, random quantum fluctuations, tiny random fluctuations in the values of the elementary particle fields, could have caused it to change into a true vacuum or into another false vacuum with lower energy. To clarify, a true vacuum in this context refers to a region of space with minimal energy, which does not necessarily have to be zero. In fact, a true vacuum can very well contain mass and energy. There just must be no state in which this region contains even less energy, because then it would be a false vacuum. Transferred to a cosmic context, this means that the change of state of the inflaton field set the inflation of the universe in motion. However, during its transition from one vacuum state to the other, the said field also emitted energy in the form of radiation and matter, practically creating its own brake pad that ended the inflationary growth phase and allowed the universe to expand at a normal speed from then on. Well, at least that's the widely held theory. And yet, there are experts who have their problems with this established view. These include, for example, the American physicists Paul Steinhardt and Alexander Vilenkin, who, as early as the 1980s, put forward the thesis that cosmological inflation did not, in fact, come to a complete standstill. In simple terms, random quantum fluctuations could also give rise to individual bubbles in which the inflaton field takes on the appropriate value to end inflation. Elsewhere, however, inflation would continue unabated, with the reverse conclusion that what we commonly call the universe is, in fact, merely a bubble-shaped subspace in which our world could unfold. In the same breath, however, this theory also entails another no less exciting fact. Because if that is really the case, then there must also be other bubbles in which other universes have formed. In this context, the Big Bang would no longer be the literal beginning of everything, but merely the beginning of the inflation. In this model, there is no such thing as a beginning of everything, only eternal inflation, from which new universe bubbles repeatedly split off. The James Webb Telescope's mysterious discovery raises the question: has our universe been swallowed by another? One of the greatest mysteries of modern space research has once again been confirmed by the James Webb Telescope, leading to the breathtaking conclusion that our cosmos might have collided with another universe bubble. To understand this, let's first address the Hubble constant, which indicates the speed at which space is currently expanding. If we determine this value using theoretical models and cosmic background radiation, we get a Hubble constant of 67 kilometers per second per megaparsec. However, when calculated using supernovae, red giants, gravitational lenses, and variable stars, the constant increases to 73 kilometers per second per megaparsec. This problematic deviation means the universe is expanding faster than it should, a fact recently confirmed again by the James Webb Telescope. Webb revisited more than 320 variable stars, known as Cepheids, and proved that the discrepancy is indeed real. But how can this be? Why don't our models align with actual observations in space? Some experts theorize that exotic particles, dark energy, or dark matter might be at play. However, A recent study by Yanamorn and Yuki Wabi, published in the Journal of Cosmology and Astroparticle Physics, offers a different perspective. They suggest that the accelerated expansion of the cosmos could be fueled by constant merging with other universes. According to their hypothesis, the merging with baby universes better explains the observed data than the standard model. They demonstrated that these mergers would increase the volume of our universe, a phenomenon our instruments detect as cosmic expansion. The researchers even calculated the expansion rate resulting from these mergers, finding their values align more closely with real observations than traditional theories. Additionally, the study challenges the idea of the inflaton field as the cause of the early universe's exponential growth spurt. Instead, they propose that our young cosmos was swallowed by a larger mother universe, which subsequently began colliding with and absorbing other baby universes. This hypothesis, if correct, suggests a new perspective on the origins of cosmic inflation and the Big Bang. However, it does not solve the ultimate mystery of how the mother universe itself was formed. In this sense, the question of the true beginning remains unanswered, as the chain of origins is simply extended further. Whether the standard model or the baby universe theory better explains the current expansion of the universe is a question only the future can answer. And while we await these answers, the expansion of our community is something we can explain quite easily by inviting you to click on the subscribe button. Don't forget to like and subscribe so you never miss a new video from us. See you soon.